Once again, and welcome to chemistry tutorials with tutor Taye Manuel. And today we are going to be solving a practical question. Here's the question, and we are going to be carrying out this experiment as related to the question, as you can see it displayed on the screen. So I put my funnel inside the burette. Just for emphasis sake, it's good to re-identify the apparatus that are here so that we can be on the same page. This is the retort stand which is holding the burette. This is the burette, this is the pipette, and my pipette is 25 cm cube, 25 milliliters, which is the same thing as 25 cm cube. There are others that could be 20 cm cube, but the one I'm using is 25 cm cube. Here is the conical flask. Here are my beakers. One labeled A, the substance A, and the other one labeled B, which contains the substance B. And here's my indicator, the methyl orange. Now, because of the nature of the substance I'm using, methyl orange is the appropriate indicator to use. Other indicators include phenolphthalein, methyl red, and the rest of them. And of course, this is the funnel. Okay, so I'm going to put A inside the burette. It reaches the 0 mark. Now it's a little above the 0 mark, so I'm going to reduce it a bit till it gets to the 0 mark. Yeah, so this is now at the 0 mark, so it has to be the lower meniscus, so it's now at the 0 mark. So I'm going to pipette the B. Now watch, anytime you are pipetting and there's bubbles, always return back. Okay. So I don't have bubbles. The essence of that is if you are pipetting and you notice bubbles, you are most likely going to suck the substance B. So to avoid that, you should be careful to avoid bubbles. So I'm releasing it a little bit till it reaches that mark that will give me the exact measurement of 25 cm cube. So I'm almost there. Okay. Now here it is, lower meniscus resting on that mark. So I have it already. So I'm releasing it inside the conical flask. Okay, so that's it. So I'm going to add just 2 or 3 drops of the methyl orange indicator with the pipette filler. I have 1, 2, another one more, 3. So those are the drops. Okay, so I'm going to titrate till the color changes. Procedure. I believe this video will help somebody. Kindly subscribe for more videos like this. Okay, so from the titration we did, the titration I just demonstrated for you, not quite long. So this is the results of the table that came out from that titration procedure. So when you want to present your titration table, here is how we go about it. So you are going to write first the volume of the pipette used. you have to indicate the volume of pipette used, because there are two of it. There is either the 20 centimeter cube or 25 centimeter cube, but the one I used is 25 centimeter cube, and these are the reading. So from here, I'm going to proceed to the average volume of A used. Okay, so I want to use the first title plus the second title plus the third title divide by 3. And my first title, I have 17.10 plus the second one 17.00, the third one also 17.10, all divide by 3. So by the time I add it together, 17.10 plus 17.00 plus 17.10, you give me 51.20 divide by 3. So by the time I divide this by 3, I'm going to have 17.07 centimeter cube. Now I would like to stress some important points that will make you have all your quality marks as far as the table presentation is concerned in titration procedure. Okay, is that your table presentation must be in 2 decimal places. Your units must well be positioned. It's either you position it here or you position it vertically like this. Either way is acceptable. The values you are getting on your table must be within the range of plus or minus 0.1. As you can see, all my values are within that range of plus or minus 0.2 rather. Plus or minus 0.2 is within that range. Now if you are picking 2 values, you will divide by 2. If you want to take your average by picking 2 values, pick values that are closest within the range of plus or minus 0.2. Then divide by 2. Now this kind of value, 17.07, was possible here because I'm taking an average. However, your burette cannot measure 17.07. The graduation of the burette measurement cannot measure 17.07. So you cannot have a kind of value like this on your table. So when we say you should present your table in 2 decimal places, what we are saying is add 0 at the back of whatever you are getting. The graduation of the burette is like that of the ruler that measures 1 decimal place. But to make the table neat, you put 0 at the back of your measurement, so it's going to be in 2 decimal places to make it well presented. However, you cannot have something like 17.01. That's wrong. You cannot measure 0.01 using the burette. Is that taken? So take note of those important points. Another thing again is avoid arithmetic error. What do you mean by arithmetic error? Imagine I have 17.10 here. If I minus it, I'm now writing 17.20. That's arithmetic error. So that's going to be a deduction. And avoid cancellation on your table. Let your table be well presented, neatly. Avoid any form of cancellation. Okay, so the question I showed you the other time, we now proceed to solve them one after the other. The question read thus: A is 3.65 grams of HCl in 500 cm cube of solution. B is 10.60 grams of X2CO3 per dm cube of a solution. Titrate A against 20 or 25 cm cube of B using methyl orange as indicator. Repeat the titration 2 or 3 more times and record your results and calculate the average volume of A used. So you have the chemical equation, as you can see from the question, and you have the following relative atomic masses that are needed to solve all the questions that would follow. So the first thing we are calculating is concentration of A in moles per dm cube. Our first calculation is to calculate the concentration of A in mole per dm cube. Okay, so from the information we are given that A contains 3.65 grams of HCl in 500 cm cube of a solution. Okay, So A contains 3.65 grams in 500 cm cube of a solution. So for me to change this to gram per dm cube, I'm going to say 3.65 times 1000 divided by 500. 1, 2. 3.65 multiplied by 2, that will give me 7.3. 7.3 grams per dm cube. So I'm now going to use this formula to get what I'm looking for. Concentration in mole per dm cube, which is the same thing as molar concentration, is equals to concentration in gram per dm cube, also known as mass concentration divided by molar mass. Divide by molar mass. Now the molar mass of A, since A is HCl, molar mass of HCl from their relative atomic masses, H is 1, Cl is 35.5. So add that together, that will give me 36.5 grams per mole. So by the time I put it in this formula, I'm going to have 7.3 over 36.5. And if I divide that, 7.3 divided by 36.5, that will give me 0.2 mole per dm cube. Okay? So the next thing we are looking at is concentration of B in mole per dm cube. Concentration of B also in mole per dm cube. That's our second calculation. The concentration of B in mole per dm cube. So I'm going to make use of the mole ratio formula. CAVA over CBVB is equals to NA over NB. So I'll make CB subject of formula. CB, if I make that subject of formula for my knowledge of mathematics, I'm going to have CA, VA, NB over VB and A. So what's my CA? The concentration of A, 0.2. My VA is my average volume of A used, which I got 17.07. My NB from the chemical equation, you will clearly see that it is 1 that is in front of a B. Because this X to CO3, from the chemical equation, you will see that it's 1 that is there. And VB is my volume of pipette, which is 25 cm cube. Then multiplied by Na, you have 2 in front of HCl from the chemical equation as depicted from the question. So if I solve this, I'm going to have 0.2 multiplied by 17.07 multiplied by 1. That will give me 3.414 divided by 50. So divide by 50, I will have 0.0683 mole per dm cube. Okay, so that is the other question, concentration of B in mole per dm cube. I believe you are still following me. So for the third one, the third calculation, we are to calculate for the molar mass of B in gram per mole. So we want to look for the molar mass of B, which of course the unit is in grams per mole. So I'll come back to this formula. Remember, concentration in mole per dm cube is equals to concentration in grams per dm cube over molar mass. So concentration per dm cube of B is 0.0683. Concentration in gram per dm cube from the question is given as 10.60, right? Divided by molar mass. That means molar mass will be 10.60 divided by 0.0683. Okay? So if I divide that, 10.60 divided by 683. That will give me 155.2 grams per mole. I can approximate this to the nearest number by getting 155 grams per mole. Okay, so the next thing we have to calculate is the relative atomic mass of X from here. So the relative atomic mass of X in H2CO3. Now, since I know that the molar mass of the compound B is 155, so let me quickly rub up this side. I believe you are still following as we are solving. So I will say X2 means that's 2X now, plus C is 12. Carbon, the relative atomic mass of carbon is 12. That of oxygen is 16. I have 3 of it. So everything is equal to 155. Okay? So 2X plus 12 plus 48. That will give me 60. Right? 60 is equal to 155. So 2X equals to 155 minus 60. And 2X would be 155 minus 60 would give me 95. Divide both sides by 2. So 95 divided by 2 give 47.5. That means the relative atomic mass of X is 47.5. So this is how we go about to solve a question that looks like this under the titration procedure, otherwise known as volumetric analysis or quantitative analysis. Okay, I believe you are able to learn one or two things from the practical procedure, presentation of the table, and how to go about the calculation. Kindly follow this channel for more videos in chemistry tutorials like this, and please share and comment. See you in the next class.